Okay, to demonstrate some of the things we talked about in the PowerPoint presentation about color, I've opened up Photoshop so that we can take a look at it in Photoshop. So if you open up Photoshop and you look along the left side here, down at the bottom is the color palette. And if you double click on one of these color swatches, it will open the color picker. So this is the color picker. Since it's right now, I've got it at default red, which is the top corner here. You'll notice that there are four different color models here: HSB, RGB, LAB, and CMYK. All right, so LAB, lab color, is something that is talked about in your textbook. You can read more about it there. We won't be discussing it more here right now. But we're going to look at the other three color models. So CMYK, as we mentioned, is cyan, magenta, yellow, and black, key color black. In this color picker, we're at pure red, which is 100% magenta and 100% yellow. It has no cyan in it and no black. And then you'll notice that as we move toward the black end of the spectrum and add more black to it, the black pigment goes up, but so do yellow and cyan. So there's actually some yellow and some cyan in this, helping to make it this darker red. As we move this circle down to black, you'll see the black becomes very dark. Now, remember, CMYK is a subtractive model. So as we move toward white, all of the percentages of cyan, magenta, yellow, and black all will get less. As you can see, I'm moving it up toward the white, and pure white has nothing. No cyan, no magenta, no yellow, no black. So that's just the color of your paper. If you were to print it, it would be a white sheet of paper. Okay, HSB is, if you remember, hue, saturation, and brightness. The brightness of white is 100%. Because it is completely bright, it is white. If I drag it all the way down to the black, there's no hue, no saturation, and no brightness. It is just completely black. Drag it up to red. The hue is 0. The saturation is 100%. It is as red as it can be. It's completely saturated. That is pure red. Its brightness is also 100%. It is a very bright red as opposed to a dark red. This is a very bright red up in the corner. Pure red is very bright. So in the RGB model, red, green, and blue, which we'll be using for most things in this course, you'll see that the red channel, R, is 255. 255 is the maximum. These scales go from 0 to 255. So that is pure red. As I drag it to the left, it's adding green and blue pixels to make it white. So in this additive model, as the number goes up, it gets closer to white. So when all of them are 255, it is pure white. If I drag it all the way down to pure black, you'll see that red, green, and blue channels have 0. There is no red in it, no green in it, no blue in it. It is completely black. The last thing I wanted to mention to you was hexadecimal code. Hexadecimal code, color code, is, as the name implies, 6 decimals. So there's 1, 2, 3, 4, 5, 6 zeros. Those zeros represent, the first 2 zeros represent the red channel, or R. The second 2 channels represent the green channel, G. and the last two represent the blue channel, B. So when they're black, in RGB, that's 0, 0, 0, 0, 0, 0. It has no color to it whatsoever. If we were to put it in pure red, it would be FF 0, 0, 0, 0. The scale goes from 0, 0 to FF. So if I take it down to black and drag it toward white, you'll see that I want you to just take a look at this first digit. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and then they ran out of numbers, so it goes after 9 to A, B, C, D, E, F. So pure white in the RGB model, hexadecimal code, is FF, FF, FF. That means it has the maximum number of red light, the maximum number of green light, and the maximum number of blue light, making white light. If it was just red, it would just be FF for fully red, no green, no blue. So if we were to change the middle two in the hexadecimal to FF, that would be green, because it's red, green, blue. If we were to make the last two digits FF, it would be pure blue. As you can see, pure blue in the RGB model, no red, no green, because it's 0, 0 for red, 0, 0 for green, and fully FF for blue. Now, then if we were to leave one of these three channels completely at 0 and the other maxed out, we could get our secondary colors. So magenta, cyan, and if we did FF, FF00, yellow. Again, all of these zeroed out is black, and all of them maxed out is white. Okay, that's all for now. I encourage you to open Photoshop and play around with the ColorPicker and get very familiar with the different values that you can place in here.